In this lesson, we are talking about volumes of solids of revolution. So a solid is created when we revolve some flat surface around an axis, and an axis is just a straight line. So as we revolve this function and all of the area underneath it around the axis, it like fans out and fills in all of the empty space that it goes through. So we can see this shape that has been revolved around the x-axis, and it has created this kind of trumpet-looking shape. We have a flared end around over here and a flared end over here. From watching that other video, we know that if you slice this, you are going to get a circle, because revolving one point around a center point. I'm going to show you if this is the x-axis and then this is the point up here at the top. If you revolve that point around here, you go out of your paper, and then you come back to the paper, and then you come back. So we've just created a circle by revolving this point around this point right here. And then every other point that's here is here, 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 here. All of these points also revolve, which fills in that circle. So it like shades it in. So this is called a cross section of this solid shape that we have now. Okay, so we're slicing those solid individual discs. Let's say that they have a height of 1 unit. So they are discs, meaning like a coin, basically. Okay, so they have a tiny little thickness to them. If that thickness is 1 unit, then the volume formula for that disc or cylinder, instead of pi r squared h, it becomes just pi r squared. Okay. Now, the height, the thickness of each of those discs is going to be dx, which is the change in the x values between the two spots where you slice that disc out. So if we slice here and here, the thickness right there is going to be dx. Okay. So what we're doing is we are finding the area right here with pi r squared, area of the circle, and then multiplying it times the thickness of the disc, and that finds us volume. It finds us the volume of one specific disc. Okay, so how do you find the volume of all of the discs put together? Since they're not all the same size, right? All those discs are going to have different heights. There's going to be a disc here, there's going to be a disc here, and here, and here. It looks a lot like a Riemann sum. We end up just adding all of those volumes up instead of adding all of the areas up. And to do that, we're going to do the integral that goes from A to B. So that's going to be from here to here. Okay. As we do this, the dx becomes like very, very small. We end up kind of taking a limit. It just happens as we are doing the integral. We take the limit as dx becomes very small, like gets close to 0. Cool. So the sum of all of the discs is this, and you could take the pi out. That's the only thing that has changed. I'll let you see what's going on here. R, the radius, changed from r to f of x minus the axis of rotation. So f of x is our function, which is this right here. And the axis of rotation is whatever you are rotating around. So where is your circle centered? That's the axis of rotation. So whatever that y value is, so it's going to be like f of x minus the y value. That's going to be your radius. Hopefully that makes sense. This is the radius. So that's f of x, in this case, minus 0. Cool. Notice the axis of rotation is the x-axis. If we change it so we're rotating around a different axis, you would just say the axis of rotation is a new number, so like 2 or something. So you do f of x minus 2. Cool. Now let's, instead of instead of just rotating this entire shape around the x-axis, let's cut out a line. So what this is going to do is make this shape over here. So instead of having y equals 0 as the bottom of our shape, let's have y equals c. It's hard to see that on there, but y equals c is that little bit. Okay, so we've got this shape. I'll just cover up the bottom. Okay, so we can still see f of x. However, y equals c is here. So we're only shading until we get to that line. Now, if we rotate this around the line y equals c, we still have a solid shape because there's no gap in the center. But if we make the x-axis the axis of rotation, then we end up revolving every single point that exists in the shaded region around the x-axis. This point is c units away from the x-axis. So when we revolve it down below, it is still going to be c units away from the x-axis. So this line, as we revolve it, creates a little open cylinder here in the center. Okay, and then this shape, you can kind of think of it as reflected as you draw, but it is revolved around, so it is creating those circles. So kind of what we've created is like, you know, CDs, like a compact disc or a donut, it looks like this. So you've got an open circle in the center, and then all of the outside is shaded in. That's what we've just created by revolving. Okay. So how would you find the area of a circle with the center cut out? Well, you would probably find the area of that shaded region by taking the area of the big circle and subtracting out the area of the small circle. And what that would look like is pi times the big radius squared minus pi times the little radius squared, right? That's the area of just the shaded region. If you factored the pi out, it would look like pi times big R squared minus little r squared. That would be the area. Now let's say we want to find the volume and make this a disk. So actually give it like a tiny bit of height to it. Then we have to multiply times dx, which is that height, the height of the disk, right? We're slicing this to get this shape. Okay, this will give us the volume of one disk. And then if we want to find the volume of all of the disks put together, we end up using an integral to add up all of the disks that start with x equals a and end with x equals b. Here's the pi we were talking about. This is going to be your big R squared, and this is going to be your little r squared. I'm going to zoom in there just a little bit. So the further function away from the axis of rotation is going to be your big radius. This might change depending on whatever your axis of rotation is. So we'll see some examples on the next page of different axes of rotation messing with what your inner and outer functions are. Okay, but this is going to be big R, which is outer function minus the axis, and then you square it. And that is the distance between the center of your circle and the furthest out function. And then little r is the distance between the center of your circle to the closest function. Really, you're still going up. Okay, so little r is from center just to this circle, which is just straight up. In this shape, big R is going from here to here, and little r is going from here to here. But it should be the same x value. So here to here and here to here. All right. So this is some notation that I'll be using for the rest of this lesson. Big R is the radius of the outer circle. So it's your function y1 minus h, and h is the horizontal axis of rotation. So if it's like y equals 2, this would be a 2. Little r is the radius of the inner circle, which is y2 minus h. and then you'll use this exact formula to find volume. So volume equals pi times the integral from a to b of big R squared minus little r squared dx. Okay, notice that that is not the same as big R minus little r squared. That would just be a smaller circle, not a big circle with a hole cut out. So there is a difference. You got to square, square, and then subtract. Cool. Next page, I've got this all filled out. I'll probably do a couple where I just do a big old reveal, and then I will probably do one where I write the problem out as we go. So our paragraph, if the axis of rotation is the x-axis or parallel to the x-axis, the integrand needs to be in term of x, and the limits of integration need to be x values at the points of intersection of the curves that form the region being rotated. Okay, so if the axis of rotation is the x-axis, everything needs to be x's. It can't be y's. So your equations have to be like f of x equals and g of x equals or y equals. Okay. Everything's going to have x's. If there's y's in your problem, it messes everything up. So we want to get rid of y's as soon as possible. So we're going to consider the region that is pictured to the right, and it is bounded by the graphs of y equals x squared, which I'm doing in purple for this entire page, and y equals x plus 2. That's going to be g of x, and it's in pink for this entire page. Okay, so let's take a look at the picture. So far, just look at the purple and the pink. Okay, the pink line right here is g of x. It's that line x plus 2, just from here to here. And then f of x is x squared, so that is from here to here. We are using A and B as the 2 points where our graphs intersect. So the graph of g of x and f of x intersect at x equals -1, and those two graphs intersect again at x equals 2. So A equals -1 and B equals 2. That's where we're going to start this. A equals -1, B equals 2. Awesome. Okay, all the other lines that are drawn here are going to be for the 3 problems that are on this page. In the first problem, it says find the volume of the solid formed when the region is rotated about the x-axis. So that's going to be this teal kind of color that's down here. The x-axis is the line y equals 0. So h in that formula we just talked about is 0. Awesome. Big R, the big radius, is going to be the distance from the axis of rotation to the furthest away function from the axis of rotation. So between purple and pink, pink is further away from blue. So pink is going to be the function that we use for big R, and then purple is the function we're going to use for little r. Okay, the distance from blue all the way up to pink is pink minus blue. So that's going to be g of x, which was our pink equation, x plus 2, minus the y value of that line of the axis of rotation, which was 0. Okay, so hopefully we realize that g of x minus 0 is literally just g of x, which was x plus 2. Next one, little r. As we revolve this shape, the shaded region around the x-axis, all of this area is going to fill in. But we might notice that here, there's some empty area. So as we rotate, we're going to get a cone kind of shape here in the center. It's not a perfect cone because this is curved, but it's kind of a cone that is empty here. It's more like a funnel, I would say. And we're also going to end up with an empty funnel over here. right? Revolve this around, it's a really big circle, and there's all that empty space in the middle. Okay. The distance between blue and purple is the purple function minus the blue function. Purple function was f of x minus, and then the blue function is y equals 0. So little r is just x squared. That's what that equation was. Okay. Now that we figured out big R and little r, the two radii of our problem, we can set up our volume. Volume equals pi times the integral from a to b. And we said a was -1 and b was 2 of, and I put brackets. This is big R squared minus little r squared, and then dx at the end. So big R squared is the area that we would get from revolving the pink around. Little x squared squared, I would say little x, but little r squared is x squared squared, and that is the area that we would get from revolving the purple around. So that's the empty space. This is solid space minus the empty space. And then dx is the thickness of that, the disk that we get. This is actually called a washer in calculus, talking about like the mechanical object of a washer. It looks just like a CD or a DVD. Okay. As we kind of simplify this out, we get x squared plus 4x plus 4 minus x to the 4th, and then we can take that integral by hand. Boom, we get x cubed over 3 plus 2x squared plus 4x minus x to the 5th over 5. I'm leaving the pi out in the front, but we are evaluating this from x equals -1 to +2. Since these are polynomials, we can definitely do this by hand without a calculator. No big deal there. Continuing that out, we plug in 2 into the first one, subtract, plug in -1 in for the second time. Notice that I've still got that pi on the outside, multiplied times a big old bracket. And that simplifies to pi times 82 over 5, which is 82 pi over 5. You could, if you really felt like it, get a decimal, but there's no point to it. Just leave your stuff in terms of pi unless you're asked for a decimal. Sweet. So that's what happens when you rotate around the x-axis. In the next problem, we are going to rotate around the line y equals 4. So that's going to be this dark blue up here. The problem is down here, y equals 4. So this is going to be our work, but let's just talk about the picture at the moment. Okay, we are rotating this shaded region around 4, y equals 4, that horizontal line. Okay, so these shapes are going to come up and up this way. So it's going to come up. That means that the pink line is closer to the blue line than the purple line is. That means that pink is going to be little r this time, and then purple is going to be used to find big R. Because purple is further away from blue, pink is closer to blue. Okay, so it is possible for big R and little r to change which function you're looking at depending on if your line is above, your axis of rotation is above or below your functions. You are not going to have an axis of rotation that goes through. That just doesn't happen. We don't give you problems like that. Cool, cool. So here we go. We are finding the volume of the region being rotated around the line y equals 4. So h is 4. That is the thing that's getting either added or subtracted from big R and little r. Let's focus on big R for a second. Okay, this says 4 minus f of x. So why is it not f of x minus 4? Let's take a look. The radius, big R, in this case, is the distance between blue and purple. If you take the purple value and subtract the blue value, you're going to get a negative number. Radii are not negative, they've got to be positive. So we are going to take blue, which is above, minus purple. So that's going to be the top guy, which is 4, minus the purple guy, which is below. So that is 4 minus the function x squared. For pink, for little r, that's going to be similar. That radius is here when we rotate, right? So it's going to be 4 minus the pink function, which was x plus 2. Okay, so I've got those two functions here, 4 minus f of x, so 4 minus x squared. But little r is 4 minus g of x. Notice that I put g of x in parentheses, and that's because we should be subtracting the whole g of x function. So that's a subtracting x and a subtracting 2. I combined like terms, 4 minus 2 is 2, and then minus x is negative x right there. Okay, once you have both of your radii, we're going to plug that into our volume formula. Okay, volume is pi, because they're circles, times the integral, which means we're going to add up all of the circles. In fact, we're adding up all of the discs, the washers, because of the dx at the end. It makes them thicker than no space. Big R was 4 minus x squared, and then we square it, minus little r was 2 minus x, and we square that. And again, you cannot combine terms until the squareds are gone. Okay, I distributed, so I've got x to the 4th minus 8x squared plus 16. I distributed, like foiled out the 2 minus x and got x squared minus 4x plus 4, and then I distributed the minus that was there. So it turns into minus plus minus for that pattern. Okay, taking the integral, I combined like terms inside. Now that there's no more parentheses squared, combine those like terms. Took the integral. I know I'm going a little bit fast on these, but we know how to take integrals. We get x to the 5th over 5 minus 3x cubed plus 2x squared plus 12x. Still have the pi on the outside, and over here we're evaluating from x equals negative 1 to 2 because those are still our a and b. We're still doing x values because we're rotating around a horizontal line. So plug those in. And we end up with 108 pi over 5, which is 67.858. It's not a pretty 8. Okay, and again, just kind of leave it in a fraction. There's no point to changing it to a decimal unless you're specifically asked to. All right, last one on this page, find the volume when the region is rotated about the line y equals negative 2. Y equals negative 2. Horizontal line, find negative 2. It's down here. So this time, our radius is going to move down, which makes the pink the outer function again, because pink is further away from green than purple is. Okay, you can always tell just by literally drawing a line and seeing which one is bigger and which one is smaller. So pink is going to be your big radius, purple is going to be in your small radius. Okay, when we subtract like the purple function, the x squared minus the negative 2, subtracting negative 2 is the same thing as adding 2. So that's how we know that we're getting a larger function for the radius instead of a smaller function. So it's not just x squared minus 2, it's x squared minus negative 2. Okay, same kind of deal for pink. Pink is g of x, which was x plus 2, and then there's another distance of 2. So subtracting negative 2 will get us what we need for our radius. Here we go, here's those functions. Big R is g of x minus negative 2, minus the negative 2 turns into a plus 2, so x plus 4. And little r is f of x minus negative 2, which is x squared plus 2. just like we talked about. Cool. Continuing on, we do our volume formula. See if you can set this up and work it out by yourself. I'll go ahead and let you take a look. You might pause. And our final answer is 162 pi over 5. It's worked out the exact same way as the other problems we have done so far. Awesome. Okay, so the problems we just did have horizontal lines for our axis of rotation. Everything was horizontal. So that means that every distance we used was from the top down to the bottom, from the top to the bottom, or from the bottom to the top. Okay, and then every A and B that we used was X values from left to right, from least to greatest. But what happens if our axis of rotation is not the x-axis? Let's say this time that it is the y-axis, or is parallel to the x-axis. X-axis. Y-axis. Oh, I'm looking at the wrong page. Miss Campbell. Okay, so the axis of rotation is the y-axis, or is parallel to the y-axis. Okay, parallel to the y-axis means a vertical line. Okay, those lines would have the equation x equals a number. So it's going to be like x equals, and I'm going to use the letter h again just to have some consistency there. Okay, so if the axis of rotation is a vertical line, the integrand needs to be in terms of y instead of x, and the limits of integration, which are a and b, need to be in terms of y as well. So this is new to us. Every other time a and b have been x values. So a is the left most y value. Left. Oh my gosh, bottom. Miss Campbell. Bottom. And then b is the high y value. From this picture, our graphs intersect here and here. So A is going to be the low one, which is -1. A equals -1, and B is going to be the y value of 2. Okay, since we're using this same picture for everything on this page, it's going to be those same exact pieces. Now, you might notice that this graph is just the other one rotated and flipped a little bit. Okay, so our region pictured to the right, well, down here, is bounded by the graphs y equals plus or minus the square root of x and y equals x minus 2. So the plus minus square root of x is that parabola, because you get the positive version and the negative version of that teapot. And then y equals x minus 2 is this function right here, the line. Let's use pink. I don't know where my purple marker went from last year. Let's use pink as this guy. Which is this one right here. And let's use this green. That's going to be this one. Okay, we talked about how we need all of our equations to be in terms of x when we're rotating around a line that's parallel to the x-axis. We are going to be rotating around vertical lines which are parallel to the y-axis, so everything needs to be in terms of y's. That means we need to get rid of the x. We need this equation to be x equals stuff. So how do you get x by itself? Well, you can add 2 to both sides of this. That would be x equals y plus 2. The other equation we have to get x by itself, so we are going to square both sides. Squaring both sides gets rid of the need to have the plus minus because Squaring a positive and squaring a negative both get you positive things. That turns this into y squared equals, and then square root of x squared is just x. So our two equations are going to be y squared and y plus 2. Awesome. We know our a and b, which are y values again. So when we find our radius this time, it's going to be horizontal radius because we are revolving around this way. Revolve, make those circles this way. Cool. Number 1, find the volume when the region is rotated about the y-axis. So the y-axis, let's do that in this kind of teal color. Y-axis. Okay, that would be h equals 0, right? The x value there is 0. X equals 0 is the equation of that line, so h equals 0. We need big R and we need little r. Okay, so for the green, oh, well, hopefully we noticed I used green for big R because the distance between the blue and green is big and the distance between blue and pink is small. Okay, so we're going to be doing for big R, that's going to be green, which was y plus 2. And we are going to subtract h, which is 0, which just turns into, of course, y plus 2. Similarly for little r is the distance between here and here. Okay, the pink function in terms of y is y squared. And then we again subtract 0 because h is 0. It's definitely easiest to revolve around an axis like an x-axis or a y-axis. But if it's not that axis, literally you just subtract the other thing. All right, let's find our volume. So volume will equal pi times the integral from y equals -1 to 2. So notice I put y equals. Normally when we do this, it's always x values. So since it's something different than normal, I put y equals. All right, let's make a bracket. It's going to be a dy this time instead. It is dy because as we make our shapes, our circles are the horizontal bits, like they're flat horizontally. So the discs are getting cut this way. And the change piece, the little height of the disc, the height of that cylinder, has a height instead of like a width, like it has been in our previous problem. So the change here is the change in y, which is dy. Okay, we're going to subtract two things. Big R always goes first because otherwise you get negative numbers. Big R is going to be y plus 2, and then we're going to square it. Little r is y squared, and we have to square it. And on this page, instead of working all of our integrals out by hand, because we already got some practice with that, we are just going to plug them into our calculator. So you might pause this. As you plug into your calculator and work out your integrals, you're just going to use x's. Don't try and make this into y's in your calculator. Make them x's. I would suggest plugging in maybe the green one as y1 into your into the y equals. Plug in x plus 2, and into y equals plug in y squared as y2. So you're going to be doing y1 squared minus y2 squared. Let's go ahead and take a look at what that actually does look like. While we're here, why not? Okay, so I'm going to make y1 be x plus 2, and this one's going to be x squared. Okay, of course we know that anything that says y here is going to be x's on here, just because this is the ability that we have with these calculators. Okay, I'm going to quit out of that and then go to an integral. That's going to be math 8. Nope, math 9. We're going from -1 to 2. And inside there, we're going to do y1 squared. I'm going to do parentheses. I don't know if I have to do parentheses, but I'm going to do it. y1 parentheses squared minus parentheses y2 parentheses squared, and then dx. Okay, I know dy is what we actually have, but everything we put in was y values. We put it into y equals as x values. All right, looks like it's all plugged in correctly. I get 14.4. Now, I did not plug in the pi into the calculator. So this is 14.4 pi, or you could say times pi and get 45.239. So this is 14.4 pi, which is 45.239. So either one of those is acceptable. Cool. Next, find the volume when the region is rotated about the line x equals 4. Okay, we will calculate this again instead of working out our integrals by hand. But what we know here is that h equals 4 is what we need. Okay, x equals 4 is a vertical line. So let's draw a vertical line at x equals 4. Here's 4, a vertical line. Okay, as we try and find a radius on this guy, we are going to the blue line from green and to the blue line from pink. Green is close and pink is far away. So that means that green is going to be used for our little r and pink is going to be used for big R. Okay, the bigger value is the 4 and the smaller value is this. So it should be 4 minus green and 4 minus pink, right? Because the pink x values are smaller than 4. The green x values are smaller than 4 as well. Okay. So we said pink was the large one, so it's big R equals, and it's going to be 4 minus y squared. Because y squared was that pink function. There's no way to simplify that, so I'm just leaving it as is. Little r is 4 minus, and our function there was y plus 2. So this simplifies out to get 2 minus y. Awesome. Let's write out our integral. Volume equals, there's always pi because these are always circles when you revolve, every single time. Pi times the integral. A was -1, and it's a y value. B was +2. We're doing dy because everything has to be in terms of y when we revolve around something parallel to the y-axis. Cool. Big radius is 4 minus y squared squared. And little radius is 2 minus y squared. Notice that these are not y1 and y2 anymore. So I'm going to teach you guys a trick. You know how we just plugged in basically this exact same thing right here, but now y1 and y2 are the wrong thing. I'm going to go in and I'm going to make y1 be this function, and I'm going to make y2 be this function, like the little r and the big R. So this is going to be, clear that out, 4 minus x squared. And the second one is going to be 2 minus y, so 2 minus x. So it's just big R and just little r. Okay, I'm going to quit that out, and then I'm going to use the up arrow a few times and highlight this because we are plugging it in with the exact same information. And now y1 and y2 are the correct functions. Hit enter once, and you get it down here again. Hit enter again, and we get 21.6. So our volume is 21.6 pi times pi is 67.858. Either answer is correct. Nice. One more time. See if you can pause and get the same exact answer that I get. Okay, find the volume when the region is rotated around the line x equals 7. Just gonna show you what I did last year. Okay, so h equals 7. It's way out here to the right, meaning that pink is our big radius and purple is going to be used for the small radius. This is further to the right, so we are doing green minus purple for small and green minus pink for big. So it's 7 minus y squared for big R, and little r is 7 minus y plus 2, which turns into 5 minus y. And then as you plug this in, plug in big R for y1, plug in little r for y2. Do that exact same thing. I got 152.681, which 152.681 divided by pi is 48.59987, blah, 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 with a pi next to it. 48.600 is how you would round that for a test. 48.600 pi, which is this. Cool. That's it. That's our lesson. Have an awesome day, guys.